Okay, in this video we're going to go over the procedure for finding the x and the y-intercepts for the graph of a function. Let's look at the coordinate system that I have here, vertical y-axis and the horizontal x-axis. This point right here where the two axes cross is the origin, which is labeled 0, 0, 0, 0. That's the point 0, 0. If I go 1 point over here, that would be the point 1, 0. If I go on the other side in the negative direction, this would be the point, say, if I go 1 over to the left of the origin, that would be the point negative 1, 0. Over here, 2, 0. Over here, negative 2, 0. So it should be clear then that every point on the x-axis, has second coordinate of 0. Second coordinate is 0. That is, the y is equal to 0. Now if I go on the y-axis 1 unit up here, that would be the point 0, 1. If I go 2 up, that would be the point 0 and 2. If I go down on the negative side, this would be the point 0, negative 1, another 1. This would be 0, negative 2. So every point on the y-axis has first coordinate of 0. Obviously the origin is on the x and the y-axis, so it has both coordinates equal to 0. X is 0, y is equal to 0. So that gives us the procedure for finding the intercepts of a graph, of a function, or any type of relation that you might have. So let's look at the first one here. Find the intercepts for each of the given functions. Let's do the y-intercept first because that's the easiest one to find. So based on what I said over here, if you want to find the y-intercept, the x has to be 0. Okay, so I know x has to be 0. So this point right here, x value is 0. And then you just put 0 over here with the x. Put a 0 there and a 0 there. So I'm left with a negative 6. So the graph crosses the y-axis at 0 and negative 6. I'd be somewhere down here. Okay. Now, if I want to find the x-intercepts, the y value, which in this case is represented by f of x, has to be 0. Okay, so that means I want to know, when is this thing equal to 0? Okay, so x squared minus x is equal to 0. It's a quadratic, so I can factor that into, say, x minus 3 and x plus 2. So this product is going to be 0 when, in this case, when this factor is 0 or when this factor is 0. Where the first factor is 0 at 3. So that means x equal to 3, y has to be 0. The second factor is 0 at negative 2. So the other x-intercept would be negative 2 and 0. So the graph crosses the x-axis at 3, 0 and negative 2, 0. It's important to note here that every function can have either no x-intercept, one intercept, or more than one intercept. X-intercept we're talking here. Now, if you have a function can only have one y-intercept or none. It can't have two or more. Okay. X-intercepts you can have several, or you could have none. But for the y-intercept, if it's a function, there can only be one or none. Okay, so that's your solution to that one. Let's clear this, and let's go to the next one. Okay, the one I just did was a polynomial, second degree polynomial, parabola, if you want the name of the graph. In this case I have a rational function. So again, I'm going to find the y-intercept because it's the easiest one to find. Okay, so again, the graph crosses the y-axis when the x value is 0. So replace the x by 0. Okay, so come back over here to the function. Put a 0 where the x is, a 0 here. What am I left with? Negative 4 over negative 2. Negative 4 over negative 2 is a positive 2. Okay, so the y-intercept is 0, negative 2. The graph crosses the y-axis at 0, negative 2. Okay, for the x-intercept, the y value has to be 0. Okay, so the y value is 0. So I have it there. So I want to know, when is this function here 0? When is x minus 4 over x minus 3 equal to 0? Well, since it's a fraction, it's going to be 0 only when the numerator is 0. So you can see that the numerator is 0 at 4 because 4 minus 4 is 0. So in this case we have one x-intercept at 4, 0. Okay, so x-intercept is 4, 0, and the y-intercept is 0, negative 2. Clear? And let's go to the next one. Okay, again, the y-intercept is found by simply replacing the x by 0. So if x is 0, what is the y value? Okay, so put a 0 where the x is. 0 squared is 0, a 0 here, so I get basically negative 9 over negative 3. Negative 9 over negative 3 is a positive 3. So the graph crosses the y-axis at the point 0, 3. Okay, for the x-intercept, the y value has to be 0. So, okay, in this case, the y is this h of x here. So I want to know, when is this going to be 0? So basically what I'm doing is, again, I'm just replacing, I'm putting a 0 here instead of the h. So I want to know, when is this going to be 0? Again, since I have a fraction is 0 only when the numerator is 0. So since I have a quadratic there, I go ahead and factor it into x minus 3. It's a difference of squares, so it's x minus 3 and x plus 3. So you can see that the numerator is going to be 0 when either of these factors is 0. And the first factor is 0 at x equal 3. Okay, so 3 and y has to be 0. That's one x-intercept. The second one is 0 at negative 3. So negative 3, 0 is the other x-intercept. Okay, so y-intercept 0, 3, x-intercept is 3, 0, and negative 3, 0. Clear? And we'll go to the next one. Okay, again, we'll find the y-intercept first. For the y-intercept, again, the x has to be 0. So put a 0 where the x is, but if we do that, I'm going to get negative 9 divided by 0. Negative 9 divided by 0 is not defined. So what that tells me is that I don't have a y-intercept. So this would be none. Okay, so again, a function can have a y-intercept, one y-intercept, or no y-intercept. You can't have more than one. So it's either 1 or none. In this case, it's none. Now, for the y has to be 0, so in this case, notice I just used a y instead of f of x or g of x. It's the same thing. So I want to know, when is this 0? Well, this one, we kind of did this one over here. What do we have over here? Very similar to this one over here. X squared minus 9 that I did. So that factors into x minus 3, x plus 3. So 1 x-intercept is going to be 3, 0. and the other one is going to be negative 3. 0. So let me mark this one out. It's going to be negative 3, 0. Okay, so 2 x-intercepts, 3, 0, negative 3, 0, and we don't have a y-intercept for this particular one. And these could be key points where if you're sketching the graph of a function, especially if you're not using a graphing calculator, sometimes the x-intercept and the y-intercept are convenient points to use in sketching the graph. Okay, this will conclude the video. Please subscribe if these are helping you, and we'll see you in the next video.